Hello, let's graph some functions. This is basically an extension or a continuation of what we did with the last lesson where we evaluated functions. I kind of showed you that this is what we would be doing today at the end of that video. But we're going to graph the functions today using a table of values, and then we're going to identify the shape of the graph before graphing it. So we're going to graph each function on the given coordinate plane by plotting at least 5 points from a table of values. So we have to create a table of values. I'm not giving it to you this time. That is a difference from what I showed you on the last video. So you are creating this. I'm not giving it to you. Now you might look at this and be like, well, this is just a line, and we've done this before. We have. I'm showing you with something that we know how to do, that table of values works, and then we're going to apply it to something we don't know how to do. So here we go. So the x values that I'm going to choose as much as possible are -2, -1, 0, 1, and 2. I want to kind of get an idea of what's happening to the left of 0, to the right of 0, and at 0. So that's why I choose those numbers. So I'm just going to take those numbers and plug them in for x. I'll show the work on the first one, but on the next couple, I'm going to not show as much work, just to keep the video under 20 minutes. 3 times -2 minus 4. So that's -6 minus 4. That's -10. Do the next one. 3 times -1 minus 4. That's -3 minus 4 is -7. 3 times 0 is 0. Minus 4 is -4. 3 times 1 is 3. 3 minus 4 is -1. 3 times 2 is 6. 6 minus 4 is 2. So now I have 5 points. I can put those points on the graph and connect them. And you're going to make a line in this case, but won't always make a line. But in this case, you will. -2, -10 doesn't fit. -1, -7 barely fits. 0, -4. 1, -1. And 2, 2. If I connect those, you see I've got a line. And it's an uphill line. So I'm going to write that uphill line. As it goes left to right, it's going up. Okay, that's going to come into play later on in this lesson. All right, next one. Again, I said I'm going to go a little quicker with this one. -2, -1, 0, 1, and 2. All right. 1 minus 2 times -2. So this is a -2 and this is a -2. So -2 times -2 is +4. So 1 plus 4 is 5. So 1 minus 2 times -1. So -2 times -1 is +2. 1 plus 2 is 3. 1 minus 0 is 1. 2 times 1, or -2 times 1 is -2. 1 minus 2 is -1. And then -2 times 2 is -4. 1 minus 4 is -3. Okay, now I could have rewritten that as -2x plus 1, and that might have made more sense to you. Because that negative, I kept saying -2 and subtract 2, and I kind of went back and forth with those. You should be able to do that by now, but if not, rewrite it with the x first. Might make your life a little easier. All right, let's plot those points. -2, +5. -1, +3. 0, 1. 1, -1. And 2, -3. And you probably expected this. What shape? It's a downhill line this time. As it goes left to right, it's going down. Okay. What makes them go uphill and downhill? It's the number in front of x. So in the first one, the number was a +3. That's an uphill line. In the second one, the number in front of x was a -2. That makes it a downhill line. Okay. Well, there's also something else that makes it a line, but I won't talk about that until the end. We got 2 more on the front here. Let's go ahead and scroll down to get to those. What's different about these? They have fractions. How does that affect things? Well, let's look. -2, -1, 0, 1, and 2. So if I put -2 in, half of -2 is -1. -1, half of -1, it's not a good number. It's -1/2. Because it's not a great number, I don't really want to choose -1. I'm going to skip that one. I'm also going to skip 1 because half of 1 is 1/2. They're not terrible numbers, but if you do that with the number 4, you're going to get some terrible numbers. Okay, so I'm going to give you a little trick with this. Since I get to choose my x values, let's choose x values that are going to give me good numbers. Well, what do I know half of? Well, I know half of 4 pretty well. It's pretty easy. And I also would know half of -4. So what's half of -4? It's -2. What's half of 0? 0. What's half of 2? It's 1. What's half of 4? It's 2. Okay, we'll talk about why we chose those in a little bit. So -4, -2. -2, -1, 0, 0, 2, 1, and 4, 2. What shape was made? An uphill line, right? Why was it an uphill line? The number in front of x was positive, so it went uphill. Can you guess what the next one's going to look like? If you said uphill line, you would be correct because it's got a positive number in front of x. Now, here's what I see a lot of people do. They'll say, oh, it's a fraction, so I'm going to use -4, -2, 0, 2, and 4. We'll just try that first one out. What's 2/3 of -4? It's -8/3. That's disgusting. I don't want to use that. So back it up a little bit here. I don't want to use -4, -2, positive 2 and 4. What numbers do I want to use? Well, I want numbers that are going to divide nicely by 3 because that's what I'm going to be doing. I'm doing 2 times a number and dividing it by 3. Well, those numbers would be -6, -3, 0, 3, and 6. So what's 2 times -6? That's -12. -12 divided by 3 is -4. -4 minus 1 is -5. Let's do the same thing with -3. 2 times -3 is -6. -6 divided by 3 is -2. -2 minus 1 is -3. 2/3 times 0 is 0. 0 minus 1 is -1. 2 times 3 is 6. 6 divided by 3 is 2. 2 minus 1 is 1. 2 times 6 is 12. 12 divided by 3 is 4. 4 minus 1 is 3. I did that very quickly. If you need to write that out, do it. Okay. But you should be able to get those y values by plugging in the x values. So -6, -5, -3, -3, 0, -1, 3, 1, and 6, 3. And like I said, it would be an uphill line. Okay. Now you might be wondering, why are we doing this? We already know how to do this and we know how to do it quicker. It's because of the front. Or sorry, it's because of the back. It's what we're going to be doing on the back that is why we're doing these XY tables. Okay. Before I go to the back, let's look at some of the patterns that happened. Notice how we chose -2, -1, 0, 1, and 2 as the x values for problems 1 and 2, but for problems 3 and 4, we chose different x values since those had fractions being multiplied into the variable. Whenever you have a fraction being multiplied into a variable, you want to use different x values. To get clean numbers or good numbers, we choose multiples of the denominator because the denominator is what we're dividing by. So if I have a function that is, I'll change color so you can see what I'm doing here, y equals 3/4 x plus 2, you know to choose multiples of 4. So -8, -4, 0, 4, and 8. Okay, hopefully that makes sense. All 4 of these problems made a line like we already talked about. A little foreshadowing, they're not going to make a line on the back. All right, so number 5, it's going to look like a line, watch how this works. And actually do what I do here. I'm going to leave a little space here at the beginning. All right, so we got the absolute value bars in there. So the absolute value of -2 plus 2. So -2 plus 2 is 0. The absolute value of 0 is 0. 1 plus 2 is 3. The absolute value of 3 is, oh wait, sorry, -1 plus 2. I was getting ahead of myself. -1 plus 2 is 1. The absolute value of 1 is 1. 0 plus 2 is 2. The absolute value of 2 is 2. 1 plus 2 is 3. The absolute value of 3 is 3. And 4. You know, be like, okay, that makes a line. -2, 0. -1, 1. 0, 2. 1, 3. 2, 4. We've got a line going on here. And you're right, we do. But let's go a little further with the negatives. -3, -4. What's -3 plus 2? Well, that's -1. But the absolute value of -1 is the distance from 0. It's 1. -4 plus 2 is -2. The absolute value of -2 is 2. Let's plot those. -3, 1. -4, 2. It changed direction. And it makes a V shape. And that's because of the absolute value. And it's upward facing. Okay, you'll see what a downward facing V looks like. You can probably picture it, but this is an upward facing V. Absolute values always do that. They make a V. Okay, so let's do the next one. If you don't get a V, you did something wrong. No fractions here, so I'm going to use -2, -1, 0, 1, and 2. It's going to take a little work here, so that negative in front is like a -1, but you don't times that until you do the absolute value part. So 2 times -2 is -4. The absolute value of -4 is +4. You have to do that first. -1 times +4 is -4. And then you add the 3, which gives you -1. All right, let's do -1 now. Notice how I'm erasing certain things there because I know what's going to happen. I know that the only thing that's going to change is this number. So -1, 2 times -1 is -2. The absolute value of -2 is 2. -1 times 2 is -2. Plus 3 is 1. 0 you should be able to do in your head. 2 times 0 is 0. Absolute value is 0. Times -1 is still 0. Plus 3 is 3. Now, the positive one, watch what happens. 2 times +1 is +2. The absolute value of +2 is still 2. -1 times 2 is -2. -2 plus 3 is 1. You can probably guess that when you put 2 in, you're going to get -1. Don't believe me? Try it, but it does. -1, 1, +1, 1. And then 2, -1, -2, -1. Connect them, and you get the V, but it's upside down. Why is it upside down? Probably guessed it. It's the negative in front of the absolute value. This one didn't have any sign, so we assume it's positive. Okay, so it's a positive number in front of the absolute values. That's what makes it upward facing. All right. Last shape that we're going to look at in this lesson is what happens when you have an exponent of 2. So let's do these. All right. Any fraction here on the first one? There's not. So I'm going to do -2, -1, 0, 1, and 2. This is actually the one that we did at the end of our video in lesson 3. That's a -1. And I'll put -2 in for x with parentheses. -2 squared is 4, but then I have to multiply that by -1, which gives me -4. -4 plus 5 is 1. Okay. What happens if I put positive 2 in? Let's do that one right now. Positive 2 squared is still 4. Negative 1 times 4 is still negative 4. Negative 4 plus 5 is still 1. You're going to notice that with exponents of 2 quite a bit. How about if I put negative 1 in for x? Negative 1 squared is 1 times negative 1 plus 5. So that's negative 1 plus 5, which is 4. If I do positive 1 squared is 1. Negative 1 times 1 is negative 1. Negative 1 times plus 5 is also 4. And the last one is 0. 0 squared is 0 times negative 1 is 0 plus 5 is 5. So negative 2, 1, negative 1, 4, 0, 5, 1, 4, 2, negative 1. Now this looks like a V kind of, but it doesn't quite, it's not as sharp as the V. You can see that between the points, like between the first point and the second point, it goes up 3 over 1. Between the second point and the third point, it goes up 1 over 1. It's not constant, okay? This is actually called a parabola, and it's upside down, or a U shape. Can you guess why it's upside down? Okay. You probably see that the negative in front of the x squared is what made it upside down, and you would be correct. Okay. Let's look at the last one. This one does have a fraction. It's also going to be U-shaped, but because of the fraction, I'm going to do these numbers. Okay, now we're going to do some work here. Negative 4 squared is 16. Positive. Half of 16 is 8. 8 minus 4 is 4. If I went and put 4 in, you would get the exact same thing. All right, let's do negative 2. Negative 2 squared is positive 4. Half of 4 is 2. 2 minus 4 is negative 2. What about positive 2? That's positive 2 squared is 4. Half of 4 is 2. 2 minus 4 is also negative 2. 0, the 0 is going to wipe that whole thing out. 0 minus 4 is negative 4. So let's plot these points. Negative 4, 4. Negative 2, negative 2. 0, negative 4. 2, negative 2. And 4, 4. And again, you get a U shape. But this time, it is upward facing, because the number in front of x squared was a positive. All right, so let's summarize what I just talked about there on the back. Scroll down here a little bit. Problems 5 and 6 had a V shape because of the absolute value around the variable. Problem 7 and 8 had a U shape. Make sure you are careful with your V and the U. They can look very similar. But that U shape came from the variable being squared. And that was with the exponent of 2. Any other exponent is going to give the graph a different shape. We're not going to get into that, but just understand that the exponent of 2 is what gives it the U shape. The V shape and the U shape are upside down when the coefficient is negative, and the coefficient is just the number in front of the variable, or with the absolute value in front of the absolute value. All right, so what shape will these graphs have? We're not going to graph them, but let's just look at their shapes. All right, so be as specific as possible when you do this. So number 1, basically what I look at here is there an exponent? No. Okay. Is there an absolute value? No. So it's probably a line, and in this case it is, and it is a line, but which way is it going? It's going uphill because the number in front of x is positive. Number 2, there's an exponent of 2. This is going to be a U shape. The number in front of x squared is negative 2, so it's going to be upside down. Absolute value, pretty easy to spot. This is going to be a V shape. The number in front of that absolute value is positive, so it's going to be a normal V shape, so upward facing. Last one has no x squared, has no absolute value, so it's going to be a line, but the number in front of x is negative, so it's going to go downhill. And that is a good thing to know. It's not essential that you know it, but it's a good thing to know. It can help you to understand what you're expecting to see before you even graph it. That concludes our lesson 4.